Good morning students. This is the 10th video. In the previous video we determined the solubility of a sparingly soluble salt. Sparingly soluble salt is the salt which is slightly soluble or little amount of the salt was dissolved in water. Today we determine the solubility from the conductance measurement. Conductance measurement is equal to the 1000, the solubility is equal to conductivity into 1000 by molar conductance at any concentration. That was the solubility that we determined in the previous video. So today we have to discuss about the solubility product. How to determine the solubility product of this sparingly soluble salt. Determination of solubility product. Determination of solubility product. Determination of solubility product of a sparingly soluble salt. Sparingly soluble salt. That means how you determine the solubility product of a sparingly soluble salt. Sparingly soluble salt. How you determine? We know that the sparingly soluble salt is the salt. The sparingly soluble salt. The sparingly soluble salt. The sparingly soluble salt is the salt. The sparingly soluble salt is the salt. Salt which is soluble salt. Soluble salt is the salt which is slightly soluble. Slightly soluble or little amount of the salt. A little amount of the salt is dissolved in a solvent. Dissolved in a solvent is called sparingly soluble salt. Sparingly soluble salt. That means when a little amount of the salt is dissolved in a solvent is called sparingly soluble salt. That means that is slightly soluble in water or any solvent. That is called sparingly soluble salt. And so the saturated solution is formed with a very little amount of the salt. Hence, a saturated solution is formed. Hence, a saturated solution is formed. Hence, a saturated solution is formed with a very little amount of the salt. With a very little amount of salt. So a saturated solution is formed. Saturated means when you add something more, it is not soluble. It will be precipitated. That means suppose you have a beaker, suppose this contains water, suppose you add sodium chloride, from sodium chloride you add, suppose it is soluble. That means it is called unsaturated. If you add 1 gram further, it is also soluble. Now it is unsaturated. If you add further, if it is soluble, then it is unsaturated. If you add 1 gram more, then if it will settle down. That means if you add when saturated solution is the solution in which if you add a small amount of the salt, it is not soluble. It is settled down at the bottom. And the solution is called supersaturated. So unsaturated, supersaturated, and in between them is called saturated. Saturated means no further salt is dissolved. If excess amount of salt you put and if it is settled down at the bottom without dissolve, then the solution is called supersaturated solution. If in the solution, if you add more salt, if it is soluble, it is called unsaturated. Saturated means if solution is formed when you add very small amount of it will settle down at the bottom without soluble. That is called saturated. So as is a sparingly soluble salt, a very little amount of the salt is dissolved in water. So a saturated solution is formed with very little amount of the salt. Saturated solution is formed. So an equilibrium exists. Hence the equilibrium exists. Hence the equilibrium exists between the sparingly soluble salt and its ion. What it means? Sparingly soluble means, suppose more amount silver chloride you put, suppose it is settled down at the bottom. This is silver chloride solid, and whatever it is present, it is in the ion form. Ion means Ag plus and Cl minus. So that is the equilibrium. Equilibrium means some Ag plus Cl minus combine to form solid. Again some solid will dissociate to convert it into Ag plus Cl minus. This process is continuous. This is called equilibrium. That means 5 Ag plus 5 Cl minus mixed to form 5 AgCl, settle down, and 5 AgCl from the solid converted to 5 Ag plus 5 Cl minus. That means this process was continued. That is called equilibrium. So the equilibrium exists between the sparingly soluble salt, that means which is present at the bottom of the solution, and its ion. Ion is present above it. So equilibrium exists between them. Then what happens the reaction? Suppose silver chloride, which is solid, that is in equilibrium with silver chloride, that is dissolved, they were dissociated, that were dissociated or dissolved, you can write better is dissolved, then ion is formed. When dissolved, ion is formed, Ag plus Cl minus, these ions are formed. So this is the sparingly soluble source. So there is a equilibrium exists between the dissolved HCl and Ag plus Cl minus ion, and this dissolved HCl equilibrium exists with that of the solid. So then what is the equilibrium constant? The equilibrium constant K, capital K, concentration of the product divided by concentration of the reactant. Concentration of the product is Ag plus concentration Cl minus concentration divided by HCl concentration. This is the equilibrium constant. Concentration of the product divided by concentration of the reactant. So these are called ions. This is called molecule. When this is multiplied with K, that means K multiplied with HCl concentration, capital K. Small k means rate constant, capital K means equilibrium constant. This is equilibrium constant, capital K. Multiply, we get Ag plus concentration into Cl minus concentration. This is nothing but is called as KSP, solubility product. Ag plus concentration into Cl minus concentration. So solubility product is the product of the concentration of the ions present in the solution. So solubility product is the product of the concentration of the ions present in the solution. So solubility product is the product of the concentration of the ions present in the solution. These ions are present in the solution. So this multiplication of the concentration of the ions is equal to the solubility product. So you can write here that KSP is called solubility product. Solubility KSP is called solubility product. Okay, so the solubility and solubility product, the solubility and solubility product, solubility and solubility product is interrelated, is related for any salt such as AX, BY, any salt such as follows. If AX, BY, it is solid. When it was dissolved in water, it is also AX, BY, it is dissolved, but it is called as the dissolved. When it dissolved, it gives ions X, A to the power Y plus Y, B to the power X minus. These ions are formed. So what is the equilibrium constant? Now equilibrium constant is equal to A, that means something to the power is equilibrium constant, product concentration of the product divided by concentration of the reactant. Concentration of the product is A Y plus to the power X into B X minus to the power Y divided concentration of AX BY. When this is multiplied with equilibrium constant, we get solubility product. We get solubility product. That means K multiplied with concentration of AX BY is equal to A Y plus to the power X whole of B X minus to the power Y. This is called KSP. So this is called KSP. So the KSP solubility product is equal to A Y plus to the power X B X minus to the power Y. If I relate solubility product with solubility, if we relate solubility product with solubility, KSP is equal to X to the power X, Y to the power Y. S is the solubility, X plus Y. X plus Y, where S is the solubility, where S is the solubility of the salt AX BY. So any salt you can find out the solubility product. Suppose example, I take any of the salt is aluminum phosphate. So aluminum sulfate. So for example, I take aluminum sulfate Al2SO4 3. I want to find out the relationship of this aluminum sulfate with solubility product and solubility. How we know? Now we have to take Al2SO4 whole 3 solid. When you dissolve form, we get 2Al3 plus 3SO4 2 minus 3SO4 2 minus. Then what is the solubility product and what is the relationship between the solubility and solubility product? Now the relationship between the solubility and solubility product is X to the power X. Here 2 is the X. That means X to the power X means either take AX BY. This is AX, this means this one is AX, this one is BY. X to the power X, X to the power X, that means X here is 2. So 2 to the power 2. Here y is equal to 3. Y to the power y. 3 to the power 3. S to the power x plus y. 2 plus 3. That means 4 in 3 now 3 27 s to the power 5. Then one we get such what is 108 s to the power 5. So this is the solubility product and solubility relationship for L to so forth. If anyone asks me only what is the solubility product, now my solubility product is the product of the concentration of the reactants, concentration of the ions. That means Al 3 plus to the power 2 into SO4 2 minus to the power 3. This is called solubility product. This is called solubility product and solubility relationship. This is the only solubility product. From the equilibrium constant you can find out. That means equilibrium. How you determine? Now my equilibrium constant of this equilibrium constant, concentration of the product divided by concentration of the reactant, concentration of the product divided by concentration of the reactant. Al 3 plus whole of 2 into SO4 2 minus whole of 3 divided by Al2 SO4 whole thrice concentration. Now multiply this one with K, that was equal to solubility product. K multiply with concentration Al2 SO4 3 is equal to Al3 plus the square into SO4 2 minus the whole cube. This is nothing but KSP. So here KSP is equal to Al3 plus the square into SO4 2 minus the whole cube. This is called solubility product. This is the solubility product solubility relationship. So any of the compound you can find out any of the relationship between the solubility and solubility product and only the solubility product. We also tells that how to find out the solubility. Now my formula of solubility determination is equal to conductivity into 1000 by molar conductance, that we know in the previous video. We also find out how to determine the solubility from the conductance measurement. This is the molar conductance and this is the solubility product of a sparingly soluble salt. This is the relationship between the solubility and solubility product. If any of the compound you want to take, you have to remember this formula. Any compound you can take solubility and solubility product relationship is Ksp is equal to s to the power x, that means that coefficient y to the power y, s to the power x plus y. Any compound you take, you can find out the relationship between the solubility and solubility product. It may be sparingly soluble salt or any weak salt, whatever the salt may be. You can find out solubility and solubility product relationship. From the ion, these are called as the ionic product. If solubility product is equal to ionic product, then the solution is saturated. That means if Ksp solubility product is equal to ionic product, solution is saturated. Solution is saturated. We take the saturated solution. When that means when the ionic product gradually increases, we get the when ionic these are the ionic product. These are the ionic product. When ionic product means product of the multiple of the ions, product of the ions. So when the product of the ions is equal to solubility product, by solubility product is equal to ionic product, we get saturated solution. Okay, from that also you can, if the ionic product exceeds the solubility product, supersaturated. If solubility product exceeds ionic product, unsaturated. So if solubility product is equal to ionic product, saturated, we take the saturated solution. So in this way you have to determine the solubility product and solubility relationship of a sparingly soluble salt. Sparingly means very little amount of the salt is dissolved in water. It's called sparingly soluble salt. Then conductometric titration. Next point is conductometric This one also the application of conductance measurement, conductometric titration. Conductometric titration. In this case, conductometric titration means the titration in which the end point or equivalency point is the conductometric titration means the titration in which the end point or equivalency point is determined using conductance measurement is called conductometric titration. That means the titration in which the end point or the equivalency point is determined using conductance measurement is called conductometric titration. Conductometric titration. Visible or not? Yes. It's called conductometric titration. That means the titration in which the end point or equivalency point is determined using the conductometric titration is called conductometric titration. By using the conductance measurement is called conductometric titration. Basically, titration we use indicator, phenolphthalein or methyl orange or methyl red or Persian blue or any indicator, starch, such type of indicators we have to use in order to indicate the end point of the titration. Suppose you take acid base titration, you have to use methyl orange indicator or phenolphthalein indicator, because when you titrate acid with a base, when the reaction is over, then the color of the solution is changed, then we know that reaction is over and the end point. Similar also in these cases we do not use indicator. In this case we use a equipment which is called conductance measurement, but conductance equipment. Already you did this experiment in the lab. In the lab you did two experiments, one is strong acid strong base, another weak acid strong base. The two experiments you already performed using this instrument in our lab, conductance instrument, conductivity cell. So in this that means this titration is totally based upon the instrument measure in conductance measurement instrument. So this titration is called as the conductometric titration. The conductancy of the electrolytic solution, the conductancy of the electrolytic solution, depends upon the following factors. The conductance of the electrolytic solution depends upon the following factors. 1. Number of ions. Second, charge of ions. Third, charge of ions, and third is mobility. That means velocity. Mobility of ions. So the conductance of the solution depends upon the following three factors. One is number of ions. If the number of ions is more, conductance will be more. Charge of the ion depends upon the charge. That means sodium plus, calcium 2 plus, aluminum 3 plus. Depending upon the charge also, the conductance also varies. Then mobility of the ions. If mobility means if the velocity. If the velocity of the ion is more, then conductance will be more. More ions will move from anode to cathode or cathode to anode. So this is called as the conductometric titration. Then we have to see that what is its procedure. What is the general procedure? What is the conductometric titration procedure? The solution to be titrated. The solution to be titrated. The solution to be titrated is taken in a beaker. Is taken in a beaker, and this beaker is called as conductivity beaker. Conductivity. This beaker is called as the conductivity beaker. So this beaker is kept in thermostat. This beaker is kept in a thermostat in order to maintain the temperature constant. In order to maintain the temperature constant. What is the use of it? Constant, CONSTANT, constant. In the what is, suppose I want to find out the conductancy at 40 degrees centigrade or 50 degrees centigrade, but your room temperature is 20 degrees centigrade. So in that cases, what you do? Now you keep the beaker in a thermostat where the temperature is kept constant. So it has maintained to 50 degrees centigrade. So beaker solution temperature also increases to 50 degrees centigrade. So you have to do titration, and whatever the conductivity you get at 50 degrees centigrade. But you already performed this experiment at room temperature. So there is no need to use a thermostat. So because we have to perform the experiment at room temperature, you also perform 2 experiments at room temperature. So there is no need of thermostat. Suppose at higher temperature from room temperature or low temperature than room temperature, in that case thermostat is required, otherwise not. So kept at thermostat. The conductivity cell is dipped in it. In it means solution. The conductivity cell means that was like a electrode, where your glass electrode, you are dipped in the conductivity cell. It dipped in it means in the solution it was dipped. Then the titrant means the solution where you take the solution you kept in that is called burette, that is called titrant. The titrant is taken in a beaker, in a burette. In the burette, whatever the solution you take, they are called as the titrant. And in the beaker, conductivity beaker, your solution was kept, whose conductancy you have to measure, in which the conductivity cell you kept. The conductivity cell is connected. The conductivity cell is connected. The conductivity cell is connected in a conductivity bridge circuit. In conductivity bridge circuit. That means conductivity bridge circuit means where you reading the note down the reading. That means where the display is display, where the display was there. That is called conductivity bridge circuit. And the electrode is called as the conductivity cell. So the conductivity cell is connected with the conductivity bridge circuit. So the conductivity bridge circuit. The titrant is taken in the burette. So the titrant is added. Titrant means in the burette whatever the solution you take, the titrant is added in dropwise to the beaker. And the solution is tired. So after each addition, the solution is stirred. That means you have to stir it. So after each titrant you add from the burette, and in the beaker the solution is present. That beaker is called conductivity beaker, and conductivity cell was kept in it. And after each addition from the burette you have to stir it. So after each addition of burette and you stir it, then the conductance of the solution is measured. The conductance of the solution is measured. Then a graph is plotted. Between the conductance and the volume of titrant added. So a graph is plotted between the conductance and the volume of titrant added. The intersection of the two straight lines is called as the end point. The intersection of the two lines, the intersection of the two lines is the end point or equivalency point. You already performed this experiment, but you did not did the graph. You also did not show it to me. So that means if you put a graph, this is the conductance and this is the volume, then you will get like the graph like this and like this. Whatever the cross section of this point, this is called end point. Okay, in the end point. So this is the titration. You already did this experiment in our lab also. Okay, I will end here. बस पढ़ापढ़ी कर बेस बुलबनी जानी आगुरी कही गवर्नमेंट सबू जगार छाड़ी बाघ फाग एरिका काली तो फास्ट गोटे पिला को नहीं पलि एपर्त से पिला फेरिनी 2 दिन है से पिला खाइनी तेणु से बाघ को जी पोषा मन से आसी रिक्वेस्ट कराऊँ छाड़ियाका बाघ मना कर सिंह मना कर तेणु उभय जेहेतु मना कर आसीपारूनी चेष्टा चली तुम्हें पढ़ कि टीवी बिल्कुल देखनी कि बाहर को बिल्कुल झरका कबाट डेंकी आसबनी खाता बही धरी पढ़ झरका बंद करदेव बाघ पशि आसो कौन कर तेणु खाली पढ़ले से छाड़ी पड़े ना पढ़ले से धरिक पड़े खाईदेव तुम भोक लगुच 2-3 दिन है से खाइनी छेली भी खाऊनी मेंढा भी खाऊनी किसी से खाऊनी खाली मनीष से खाइब तेणु तुम्हें पढ़ खाली पढ़ ओके आई विल एंड हियर।